At CES 2026, AMD laid out this really bold vision for the future of AI, and it's a future that's going to require a truly staggering amount of computing power. So what in the world is Yada-scale AI, and what's it actually going to take for us to get there? Let's dive in and break it all down. This quote really set the stage for everything they talked about. You see, this isn't just about tweaking AI to make it a little bit better. It's about creating a future where AI helps us completely redefine the limits of what we thought was possible. Okay, so to make this incredible vision of AI everywhere a reality, what's the one thing we really need, more than anything else? It all comes down to an unbelievable amount of computational power. But, how much are we actually talking about here? Well, the answer is a number that's kinda hard to wrap your head around. 10 yottaflops. That's the amount of compute AMD believes we need to power this next generation of artificial intelligence.
Just to put that in perspective, a yottaflop is a 1 with 24 zeros after it. To get to 10 of those, we need a 10,000 times increase in our global computing power from just back in 2022. That's not just a step up, it's a completely different league. It's an unprecedented jump in the entire history of computing.
All right, so where do you even start building a future like that? It all begins in the cloud. You can think of the cloud as this massive global brain that trains the biggest AI models and then delivers all that intelligence to billions of people. And the demand for this power is just exploding. I mean, look at this. On one side, training these massive AI models needs 4 times more compute every single year. But on the other side, just using the AI in our day-to-day lives, that's what we call inference, that's grown 100 times in just 2 years. It's insane.
So to keep up with this crazy demand, AMD's answer is something called Helios. This is their next-gen platform built specifically for this Yada-scale era. And let me tell you, this thing is an absolute beast. Each one of these Helios racks is just packed with next-gen GPUs and CPUs. The whole thing is liquid-cooled, and it weighs almost 7,000 pounds. That is literally heavier than 2 compact cars.
But, why go to all this trouble? Why build something so ridiculously powerful? Well, this quote from OpenAI's Greg Brockman really hits it home. The goal, the dream, is to have enough compute to deliver the benefits of AI to every single person on the planet. And that kind of scale, it's going to take billions of GPUs.
Okay, so the cloud is where all the heavy lifting happens, right? But the next big wave in AI, that's happening much, much closer to home. We're talking about the rise of the AI PC, which puts powerful AI capabilities right on your own device. So why is this local AI thing such a game changer? Well, if you look at this comparison, it's pretty clear. It means your AI can work even when you're offline. Your data stays on your device, totally private. And because it's right there, it's way faster and more responsive. No more lag. And you can see AMD has been pushing this really hard. I mean, back in 2023, they were the first to stick a dedicated AI engine right on the chip. By 2024, they're delivering the first Copilot Plus PCs, and now in 2026, we've got the Ryzen AI 400 series. The pace is just incredible. And with these new processors, combined with smarter AI models, we're starting to see some really cool stuff. Think about it, a proactive AI assistant that can literally join a meeting for you while you get other work done. That's the kind of future the AI PC is making possible, right now. So we've gone from the giant cloud to the PC on your desk. AI is getting closer and closer, but what happens when it breaks free from the screen entirely and steps into the real physical world? Well, say hello to Gene.01. This is a new humanoid robot, but the key here is the idea of human-centric physical AI. So it's not just about replacing people, it's about humans and robots actually working together, collaborating. And one of the coolest features of Gene.01 is its sense of touch. It's covered in the skin of sensors, so it can actually feel pressure and contact. This makes interacting with it way safer and, just more natural. All right, so we've seen AI on the factory floor. Now let's take it to the ultimate edge, the most challenging environment you can imagine, where there is absolutely zero room for error. Space. And this quote from Blue Origin just says it all. AI becomes a co-pilot for the astronaut. It can scan the terrain in real time, find safe places to land, spot hazards. It's becoming absolutely critical for the future of space exploration. Okay, so we've talked about massive data centers, AI on your PC, intelligent robots, but what's the point of all this power? What's the end game? Well, this last part brings it all home.
connecting this incredible tech to solving some of our biggest human challenges.
You know, this massive jump in computing power isn't just theory, it's already making a huge difference. Take healthcare, for example. We're using AI to design brand new drugs from scratch. We're personalizing medicine based on your specific DNA. And we're modeling how viruses change so we can create better treatments and get ahead of the next pandemic.
And this isn't happening in a vacuum. It's being driven by a combination of incredible technology, like the world's fastest supercomputers and these big collaborations between governments and private companies. They're all working together, using AI to solve problems that we honestly thought were impossible just a few years ago.
So as we head into this era of Yoda-scale computing, with a 10,000 times increase in power on the horizon, the question really isn't about what's possible anymore. It's about what we're going to do with this incredible new capability. With power this vast, what challenges will we solve next?